Good morning, children. Today we'll see Physics, Chapter 4, Heat. So this is the last topic of this chapter. So first let us recall what did we discuss in this chapter. So first in this chapter we saw what is heat. It is the measure of hotness and coldness of an object. So how to measure whether an object is hot or cold? We need to identify the temperature. To detect the temperature, a device called thermometer is used. The thermometer is of three types: clinical thermometer, laboratory thermometer and maximum minimum thermometer. Alright, now to measure the temperature in the thermometer, we have three different reading scales: Celsius scale, Fahrenheit scale and Kelvin scale. Celsius scale is the most used one and Fahrenheit scale also. We don't prefer Kelvin scale because it is used for astronomical studies. And then we saw the thermometer and its parts. Kink is nothing but a stoppage for the liquid inside the thermometer to flow. The thermometer's liquid is mostly mercury or alcohol because of its various advantageous properties. The normal body temperature is 37 degrees Celsius or 98.4 degree Fahrenheit. Then we use laboratory thermometer specifically for the use in laboratories to measure the hotness and coldness of the objects. Clinical thermometer will be used in the hospital, that is in the clinics, to measure the body temperature. Then we discuss the different ranges of Celsius, Fahrenheit and Kelvin scale, that is the lower fixed point and upper fixed point. The lower and upper fixed point are determined with respect to water's freezing and boiling point. So in Celsius scale, the freezing point of water is 0, boiling point is 100, and the same freezing and boiling point of water in the corresponding Fahrenheit scale and Kelvin scale were determined. I gave you a clear explanation of how to determine the boiling and freezing point of water in the three different scales and its equivalent values. Then we saw how to convert a temperature from one scale to another scale. Right? I just gave a quick recall because it's been a long time, maybe a week, I touched physics since we were busy finishing the chemistry part. Right? So, I hope you got a idea about the introduction we discussed for the heat chapter. So the next one we are going to see is the process of heat transfer. How does the heat is transferred? So read the heading properly. The processes involved in the transfer of heat. So the heading tells us that there is heat transfer happening. How does the heat gets transferred? Heat always transfers from the hot object to the cold object. Okay. Every day the sun rises. The sun is a hot body. The earth without the sun, that is during the night time, how it is? It is cold because of the presence of moon alone. The earth will be cold. Only after the sunrise, the earth becomes warm. So what happens? The heat from the sun is transferred to the earth by the radiations, by the sun rays. Yes or no? So the same way, heat is always transferred from hot object to cold object. Now take the example of boiling of water. You will keep a vessel and you will pour the water which is cold. You will not boil the hot water. You will boil only the cold water. Right? So you will pour the cold water into the vessel and the stove is on. So the heat from the stove will convert the cold water into hot water. Yes or no? Okay, so for that conversion, where is the heat transferred? From the stove to the cold water, the heat is transferred. So from the hot body to the cold body. From the stove to the cold water, heat is transferred. So always keep in your mind that the heat is transferred from the hot object to the cold object. Based on that, there are three processes of heat transfer: conduction, convection and radiation. These are the three ways how the heat can be transferred in the objects around us. Okay. The first one is conduction. Conduction means the same definition, transfer of heat from hotter end to the colder end. And the most important one is this process is noticed specifically in solid objects. As I told you now, boiling of water. From the stove to the cold water, the heat is transferred. So the cold water is filled in the vessel. Vessel is a solid object. So the heat is transferred from the stove to the vessel which is a solid. So the process in the boiling of water is an example of conduction process of heat transfer. Okay. So whenever there happens a transfer of heat in case of solid objects from the hotter end to the colder end, then the process is called conduction. Based on this only, we classify the materials as conductors and insulators. Already we have learnt the materials to be classified as conductors and insulators in the electricity chapter itself, in your last year. So there we learnt a word that based on the transfer of electricity and heat, the materials are classified as conductors and insulators. Yes or no? So at that time you asked me, ma'am, why are they telling that based on the transfer of heat and electricity? Now did you understand why is it so? So the materials can be called as conductor or insulator by noticing the transfer of electricity and heat. If a material allows the passage of heat, then it is a conductor. If it does not allow the passage of heat, then it is a insulator. Then the next process is convection. Convection is also the same thing, that is the transfer of heat from hotter end to the colder end, but in case of liquids and gases. So liquids and gases are commonly called by the name fluids. These two can be called by one name, that is fluids. So whenever I tell fluids, it represents both the liquids and gases. Okay, so we already have only three states of matter: solid, liquid and gas. Liquids and gases are not commonly called as fluids. If the process of heat transfer happens in the fluids from the hotter end to the colder end, then the process is convection. Example is your land breeze and sea breeze. I have explained land breeze and sea breeze in the later part of the video with the image. That diagram of land breeze and sea breeze is very important. Let us move to the third process of heat transfer, that is your radiation. Radiation is the transfer of heat by the form of rays. As I told you already, that is the sun rays. Okay, here you does not require any medium for its transfer. Like the process of conduction and convection, you don't want any medium here. Either it be a solid or a liquid or a gas, it is not necessary in the radiation process, because it's here the transfer of heat happens only by the form of rays. What is the use of a medium here? Right? So, these are the three processes of heat transfer. Okay, now look at this image. Here you have a pan, which is a cooking vessel, and a stove. The flame is put. Okay, so how does the heat from the stove gets transferred to the pan and we are able to cook? It is by the process of heat transfer in solids, that is your conduction. Yes or no? Pan is a solid and the heat put over there gets transferred to the pan. So it is the conduction process. Next, we are going to see about convection. So what is convection? Convection is the heat transfer from the hotter end to the colder end in case of fluids. Fluids means both liquids and gases. The common name for liquids and gases is fluids. You would have already come across the word like sea breeze and land breeze. What happens during day and night of the breeze in land and sea? What is meant by breeze? It is nothing but the blowing air, the wind. Okay, so during daytime, the sun rises and it becomes day. So the land area would be hot. The air present in the land area is warm in nature. Whereas during the same daytime, the wind or the breeze in the sea would be colder. That is why we prefer to go to beaches and all during summer to get some cool breeze. Yes or no? So that is because the land would be warm during daytime and the sea would be cool. So, how does the heat get transferred? How does the hot air from the land gets transferred to the sea and the cold air from the sea gets transferred to the land? This happens only in the daytime, and that is what is our sea breeze. This is the process of convection. The movement of air, that is the wind, the blowing air, carries away the warm air from the land and leaves it to the sea and collects back the cold air from the sea to the land, so that we can balance the temperature during summer or hotter days. So this is the sea breeze. The same process of heat transfer happens during the night time also. So, how will the land be during night time? The breeze over the land will be cold, and the breeze in the sea would be warmer, because during the entire day all the warm air from the land is being transferred to the sea. Yes or no? And all the cold air from the sea was transferred to the land. And even during the night time, the transfer of heat happens, and what happens? The warm air from the sea now travels back to the land and the cold air travels back to the sea. So this is just like a cycle. During day and night, there happens a transfer of cold and warm air between the land and sea. That is what your land breeze and sea breeze. Here, the transfer of heat is happening in the air molecules, that is in the form of a gas. So the process is convection. Now you may get some confusions while drawing the land breeze and sea breeze. Always remember that during night time it is land breeze and during daytime it is sea breeze. One kind of a clue which I can give you is, give the name for the heat transfer with respect to the cold breeze. Okay, so during daytime the cold breeze is from the sea, so it gets the name as sea breeze. Similar way, during night time where is the cold breeze? It is in the land, so its name is land breeze. So night time land breeze, daytime sea breeze. The most important thing which you wanted to mention while drawing the diagram is the correct indication of the movement of air molecules. Direction is important, and mention the correct type of breeze. Above the land it should be warm air, above the sea it should be cold air in case of sea breeze. The direction and the mentioning of the breeze should be done properly, because many people used to get confusion. That is why I am stressing upon here. The next thing is, the third process of heat transfer is radiation. So radiation does not require any medium. Any medium means it indicates that it does not require a solid or a gas or a liquid. Okay, so it is just like the sun rays. Whenever we burn some wood or charcoal, the heat is produced and we could feel the warmth if we keep our hands near to it, right? So that is because of the transfer of heat in the form of rays. Radiation is nothing but the process of heat transfer in the form of rays. Now look at this image. It is a very simple example which explains all the three processes of heat transfer. Okay, so you have a stove and a pan filled with water. You are going to boil the water. So the heat from the stove gets transferred to the pan. This is conduction. Yes or no? Transfer of heat from the hotter end to the colder end in case of solid. From the stove to the pan. Pan is cold enough and the stove is hotter. Then, once the water is boiled, the water vapors arise. So, again, the transfer of heat from hotter end to the colder end, you can collect the water vapors and condense it. Yes, so that is your convection process in case of liquids and gases. And if we keep our hands near to the stove, we could feel the warmth. That is because of the transfer of heat. Some amount of heat is lost in the form of rays. Okay, children?